Good morning, everyone. My name is Rahul Chowdary. I am representing Pace University, New York. So today I will be presenting a risk-driven CI/CD framework for faster, more secure delivery. The main idea is simple. In modern software delivery, security and speed should not fight each other. If security is applied the right way, it can actually help teams release faster and safer. In many organizations, especially financial services, every release goes through security checks, compliance reviews, approvals, and manual validations. These controls are important, but when they are applied equally to every change, they slow teams down. The question I focused on is, can we make CI/CD pipelines smart enough to apply the right level of security based on actual risk? That is where the risk-driven framework comes in. So the biggest challenge is that security and speed are often treated like opposing goals. Engineering teams wanted to release quickly, security teams wanted to reduce risk. Compliance teams needs evidence and control, but additional pipelines usually apply the same gates at every change. For example, a small UI text change and a change to an authentication module may go through the same security process. That creates unnecessary friction. These are the three common problems. First, release friction. Second, late detection. Third, compliance burden. So the core problem is not the actual security exists. The problem is that security is often applied in a static, uniform way. So the core insight is not every change carries the same risk. So the framework overview. The framework has 4 pillars. Every change is scored based on its own actual risk, like policy as a code. Security and compliance rules are written as code, version controlled, automatically enforced. Adaptive controls, the pipeline adjusts the depth of scanning and approvals based on the risk score. Automation remediation, when known issues are detected and system can trigger fixes automatically instead of waiting for manual intervention. So together, the 4 pillars create a CI/CD model that is faster, more measurable, and more secure. So pillar 1, dynamic risk assessment. The first pillar is this. Here, every commit or pull request is evaluated in real time. The system looks at factors such as code surface area, how many files changed, how many services are affected, is the dependency graph impacted, and data sensitivity. Does this change touch customer data, payment data, authentication, authorization, or any regulated workflows? Historical signal. Has this component had vulnerabilities in the past? And environment context. Is the change going to development, staging, or production? What environment is it? For example, a small front-end label change may be low risk, but a change to an API authorization function or Terraform production network rule would be high risk. This allows the pipeline to decide what level control is needed. The benefit is that teams avoid deep scanning and manual approvals when they are not necessary, but high-risk changes still get the attention they deserve. Pillar 2, policy as a code at scale. In many organizations, security rules live in manual checklists, spreadsheets, emails, or tribal knowledge that does not scale. With policy as a code, security rules are written as machine-readable policies and stored in Git. That gives 3 big advantages. First, policy becomes auditable, and the second one is policy becomes consistent, then the third is policy becomes automated. For example, policies can enforce that no critical vulnerabilities are allowed in production, containers must come from trusted registries, secrets cannot be committed to source code, infrastructure changes must follow approved patterns, SBOMs must be generated for release artifacts. Pillar 3, adaptive controls. So this is where the framework becomes practical. Instead of one standard pipeline for every change, we create control tiers. A low-risk change may require basic unit tests, lightweight scanning, and automated approval. So a medium risk change may require SAST, dependency scanning, container scanning, and peer review. A high risk change may require deeper security scanning, threat model review, approval from security, additional compliance evidence, and stricter deployment controls. So this makes security proportional to expose. We are not reducing security, we are placing security where the risk is highest. And the pillar 4 is automated remediation. So traditional pipeline often stop at detection. So they find the issue, fail the build, and leave the developer to figure it out. So that creates delays. In this framework, when the pipeline detects a known issue, it can trigger the next action automatically. For example, if a vulnerable dependency is found, the system can create a auto upgrade pull request. If post-deployment monitoring shows abnormal behavior, the pipeline can trigger rollback. So the key point is that automation should not be blind. It should be based on known patterns, strong measurement, and safeguard rails. Production results. So this framework was validated in a highly regulated financial services environment. That context is important because financial services has strict controls around security, auditability, release approvals, and risk management. So this framework helped reduce manual review bottlenecks while keeping compliance evidences continuously available. The major outcomes were deployment frequency improved because smaller, safe releases becomes easier. Compliance improved because approvals, scan results, SBOMs, policy decisions were captured automatically. The key metrics. The most important metric is the reduction in mean time to detection. Previously, vulnerability could take around 18.4 days to detect. With pipeline integrated controls, detection dropped to about 0.3 days. That is a major improvement because it means issues are found close to the time they are introduced. This reduces exposure window and makes remediation easier. The framework also supports other metrics such as vulnerability detection, fewer security related rollbacks, automated compliance, reduction in overall risk score, build time, overhead. A pipeline that is secure but painfully slow will not be adopted. A pipeline that is fast but unsafe creates business risk. The goal is to balance both. So deep dive detection velocity. So the reduction from 18.4 days to 0.3 days shows why embedding security into CI/CD is so powerful. When detection happens after deployment, teams have already moved on. The code is live, customers may exposed, and remediation requires coordination. But when detection happens during commit, pull request, build, or deployment, the feedback loop is much shorter. This is also changes compliance. Instead of collecting audit evidence manually at the end of the quarter, the pipeline generates evidences continuously. Every scan, approval, exception, artifact, SBOM, and policy decision becomes part of the release record. So measuring success. A strong security framework should not only measure activity. For example, counting how many scans were run does not prove the risk went down. Instead, we should measure outcomes. The 4 dimensions I recommend are security outcomes, delivery outcomes, compliance outcomes, and developer experience. So this balanced measurement is important because improving one area should not create hidden problems somewhere else. So a practical guide for organizations that want to apply this framework, I recommend 4 steps. First, baseline your risk profile. So start by mapping your services, identify which systems handle sensitive data, authentication, payments, customer information, or production infrastructure. Second, start with policy as a code for compliance. Do not try to automate everything at once. Begin with the most painful manual controls. These usually deliver quick wins. So third, instrument before you automate. Measure false positives, scan accuracy, build time, and remediation time before expanding automation. Fourth, iterate on tier thresholds. Risk scoring is not perfect on day one. Review the model regularly using real incident, data rollback, data, and developer feedback. So the framework should evolve as the organization learns. So key takeaways. There are the 4 main takeaways. First, risk-based control reduction reduces friction. Security does not need to slow every release. It needs to focus on the riskiest changes. Second, policy as code is foundational. If policies are not codified, they cannot scale. Third, measure outcomes, not just activity. The goal is not more scans. The goal is faster detection, lower risk, fewer rollbacks, and strong compliance. Fourth, automation requires instrumentation. Automated remediation is powerful, but it must be supported by accurate measurement and guardrails. So to close, the main message of this presentation is CI/CD security should be intelligent, adaptive, and risk-driven. In modern software delivery, organizations cannot afford to choose between speed and security. By combining dynamic risk scoring, policy as code, adaptive controls, and automated remediation, we can build delivery pipelines that move faster while reducing risk. Security becomes part of the engineering workflow, not a separate checkpoint at the end. That is the failure of secure software delivery. Thank you.